Hi, welcome to another episode of PX and the Art of Programming. My name is Perry Winkel. I am Dutch. I live in Arnhem in the Netherlands, close to Germany. I have taken up the work on this project in the late 1980s. It's all about something about 40 years ago. That's quite some time, don't you think? No, 30. No, 2019. No, 30 years ago. 31 years ago. The aim of the project is to find out how to write infallible code. And the answer to writing infallible code is not a simple monostatic, what do you call it? Monolithic. It's not a monolithic simple answer. There are many disciplines involved in writing infallible code, in writing non-questionable code. I'm having a sip of tea. The last two episodes that I held about the structure px1micro, I would advise you to watch them for the intro. I will not repeat that information now. In this episode, I will focus on the formatting of code and the px_begin macro and the return px_ok. But these two belong together, including the return value of every function, which is a px status. It's all about having complete control over your code. First, a word about formatting. As you can see, this function has an indentation of one step. Oh, there's one tab. So the first line, which tells the name of the function, starts at an indentation level of 0, and then the content of the function has an indentation level of 1. And within the content, we find a piece of debugging, a group of debugging statements, and they have an indentation of 2. Oh. This is equal to the indentation that is used. This is my Macintosh. No. This is the same implementation, as you can see. No? You get the picture, don't you? No? It is common in amongst programmers, especially C programmers, to use a different way of indentation for programming code. And this is not necessary. Though your eyes are used to this way of reading indented stuff. This is how we indent. This is how we use indentation to represent a tree structure. So it is unnecessary to use another way of indentation for your computer code. Don't you agree? That is the reason why this software is indented this way. Let me see if I can find an if statement. Yeah, here we have an if statement. This is the if statement. And then the content of the if is indented. And the else statement is at the same indentation level as the if, because it's at the same level, of course. And then the else content is indented with 2 indentations. 1, 2. 2 tabs. Okay? If, and then we have 3. 1, 2, 3. 1, 2, 3. So there's no question about it how to indent, I believe. No? Furthermore, this function applies a discount percentage. So if we have a discount of 10% and we have an original price of, say, 100, then if we apply the value 10 using this function, then the result value will be 90. I have written this function with this rather long name for those cases in which I worked a lot with discount percentages in accounting software and logistics software. And I did not want to write it all out because it's quite hard to... if you have a percentage of 10, you have to write 100 minus the percentage in between parentheses divided by 100. And then applying that fraction to the price. If you do this in normal C, then C will use at some point a floating point operation, or it will do the rounding in a terrible way. And in this way, your result is guaranteed optimal. So here we see the implementation of the function. This structure holds, for instance, a price. And then this is the discount percentage that should be applied to the price. Then we start up with a temporary variable, it's called m, because it has no meaning in itself, it's just a micro. We put the value 100 into it. Then we distract the discount percentage, subtract it, and then we divide the result by 100. And then we multiply this fraction against the content of the micro. And this operation is done with an integer precision. In the debugging code, first step, we check the integrity of the micro class struct. Then we demand that the discount percentage is not a negative number. And we demand that the discount percentage is less than 100, less than or equal to 100. You can argue that if you could add, to write really perfect code, you could write something like if the discount percentage is empty, and you can return immediately. This you can have some discussion about, because if there's no discount to apply, then you don't have to execute these 4 lines of code. Agree? Coming to think of it, I think this is a good statement to add to this function. Yeah. You can think of something like if the discount percentage equals 100, and then execute the clear. If the discount percentage is 100%, then the micro itself should be completely erased, don't you think? Huh? But I don't think this piece of code will speed things up. But maybe this piece of code will. And the check whether or not a micro is empty is very, very fast. It'll take a couple of cycles, computer cycles, not more. And these are things to think about when you write code. You want to write the fastest code as possible. Well, let's have a look at this macro, px_begin. And here you can find the definition. You can look it up by searching for define space px_begin. And it will lead you to px0assert.h, the assertions. And here you can find the definition of px_begin under debugging mode. And here you can find the definition of px_begin when running actual code. And you can see that under debug there are 2 extra variables declared. But always what is declared are 2 variables. One is a status variable initialized with px_ok, and a byte, a single char, and it is initialized with a 0. The B stands for Boolean value. The thought behind this is that a simple Boolean is used in almost every function. And the declaration of a single char and emptying the content of a single char will take 2 cycles, not more than that. 3 cycles, 4 cycles. So if we have declared this variable being of type pxStatus and this variable being of type pxB, well, here we do not use the variable b, as you can see. But we will encounter functions that do. We do have the use of the execution macro. And the execution macro is used to execute a function. So every function returns a pxStatus. And therefore, it is useful to execute a function by using the px_exec macro. And this will become clear if you look at the implementation of the execution macro. And it is defined here. So, execution of a job, a function, or whatever, has the following implementation. The result of job is put into my status px_exec. And if this is not okay, then if there was a user stop, meaning a user has asked for the cancelling of this job, maybe the job took too much time, and the user pressed the cancel button. Are you sure you want to cancel this job? And the user said yes. Well, then the function returns with the status not equal to px OK. And not much will happen, because if a user cancelled an operation, then this will be logged with the name of the job and a return with the px user stop. A user has stopped a job. It is logged, but it is not an error. On the other hand, if it wasn't a user stop, then it's an error. px.ko. And then an error will be raised with the message no execution, and then the name of the job, and the px.ko value of px status is returned. Okay? In this way, every function that calls another function that ended in an error will itself end in an error automatically. So if micro value subtract should fail for some reason, maybe an underflow, then this function will fail. And the function that called this function will fail also. And that you will get a complete stack of all the calling functions that failed due to the fact that some function way down below in the function chain ended in an error. And you might argue, well, if I use GDB, I will get the same functionality. Yes, you do. Given the fact that all your functions will raise an error, and you have to run the program under GDB. But not with px. Just having a bit of tea and a pause. If I run this software on an operational server, then there's no GDB around. There is not even a debugging mode active. But if a user hits a button that leads to an exception not recognized by the software, a situation which was not expected, then the error logging will start. And you, as a programmer, will see all the errors, including the names of the source files and the names and the line numbers where the error occurred. I have demonstrated this in a former episode concerning the px1micro. Well, now I will go into a piece of test code. And I will look at the thing overflow. The phenomenon of overflow. Well, first of all, if I define a string this long, 0, 1, 2, 9, and then up to 9. So it's 20 digits. Well, a micro cannot hold this accuracy, because a micro has the maximum positive value of 4 times times 4G, 4 giga times 4 giga. So this should fail. No? The function micro value set will return a value pxko, and the boolean, which informs the calling function that the setting of the micro went okay, the address is given. And this boolean is declared by px_begin. And I think that's all the way to the top, to the start of the testing function. This is a classical case of overflow using the value add function. First, we put into the micro the value of pxn minus 1. This is the maximum number for a 64-bit number. Agreed? And if we add something to this value, then it should fail. So this is checked in the test code. The test code guarantees that overflows will end in a px knockout. This is another example of a px knockout. And this is an example of an underflow. We have the maximum value for a positive number, 64 bits. We multiply it by minus 1, and then we add minus 100 to it. It should fail. So we are protected from overflow. And here are some tests for underflow. For instance, if we have the value of 1 and we divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, there's 1 billion. This should not be, this is an underflow, because the smallest fraction that we can hold is 1/millionth. And this is another example. If we have a value of this 1/millionth, I think. Yes, this 1/millionth, and we divide it by 1,000, then it will fail. All checked in the test code. And once again, I stated this already in the former episode on nomenclature. This macro means px okay always. And this is a statement, an expression that should be true always. So if we decided to divide a macro with a value of 1/millionth by 1,000, then it should always be the case that the status of this function, the return status, is pxko. This is the way to write infallible code. Of course, software can fail, but if it fails, px will report to the maximum that what has gone wrong. And if you take into practice that when a user reports a bug, then the first thing that you do is that you extend your debugging software, the testing code, and then you see to it that this case that the user has found is put into the testing software. Then the testing software will, of course, fail on this issue, and then you repair the bug. And then you have accomplished two goals. First of all, the bug has been fixed. Second of all, such a bug will not appear again. because the test code has been extended. And if you have enough testing code, then bugs can never ever survive. And px comes with a lot of testing code. Well, let us have a look at micro value divide. To see if I can come up with some interesting things to tell you about this software. First of all, the value should not be empty. The value by which you divide, not ever. And the first thing, furthermore, if the value itself is empty, well, then 0 divided by 100 is 0. So if the value itself is empty, then we can return. In the debugging environment, we declare a local variable m, px1micro, and we put the current value of this micro into m for later use, namely for checking the result. Then we call the function with the actual divide, and then we start to check. You can argue about the level of checking. But the first thing that I check is if one of the two, and what I do here is I have a second micro, M1, and I put the result after the division into it, and then I multiply it with the factor, the value. And it should be the same, don't you think? So M1 should be equal to M. The first thing that we check is whether or not one of them is filled and the other not. Or if they're both empty, okie dokie, then they could be equal. If they are both filled, well, they could be equal. But if one of them is filled, then something is wrong. And we return a px_KO. We do not work with a px OK always here, because we do not want that this test code, where was the test code? We do not want the test code to produce a log in the error log. Now and then we have a check whether M1 is equal to M. And if this is not the case, then we'll do some checking on the way they differ, the amount that they differ. And here I have decided that a difference of more than 1% is not acceptable. But yeah, you might argue, what is reasonable? Well, we always have the problem that the accuracy of a 64-bit structure, even 128-bit structure, the accuracy is limited in every case. And here we do the check by working with doubles. So there is work and some work done with using doubles, floats, but only in the debugging code, not in the real code. And the micro value divide is over here. This does the actual division. Maybe this under debug should go. Yeah, I think I'm writing perfect code. I think under all circumstances it should be checked that the value by which the division takes place is filled. And this is the date of today. Not only under debug, but just to be safe. So whether or not this, whether or not the value is filled, it's a very fast check. It will not take many computing time, but it will save you from any problems. Really nasty problems. And here comes some very nifty code that I've written to do the division with integers. And then I use the trick to shift left and to shift right. To shift a number to the left means multiplying it by 10 or 100 or 1000. And to shift a number to the right means dividing it by 100 or 1000, whatever. Just to have an optimal use of the bandwidth, you might argue, the bandwidth of a 64-bit integer operation. You want to have the maximum accuracy. I'm not going to discuss all the ins and outs of this code. But it should be readable. I've worked with a lot of empty lines, and I thought about these empty lines. So this program, this function, tells a story. And the code is the story. So it's a thing to read for a rainy night, a rainy evening. And maybe you can learn something from it. To learn how to write code. For instance, if it is just, if there are no fractions in case, then we can just divide, a simple divide. Uh, 4 divided by 2 is a simple 2. And in the implementation, we can see that the micro value multiply is a public function. And the micro value divide with the underscore at the start, and multiply. They are private. One could argue that many of these functions should become private. Like micro value shift left. I will work on this. Writing really good code is equal to polishing. You do it again, again, and again, and again. Just as long as the code starts to shine. What I also like is to not to work with a section of public functions and then a section with private functions. I would like to name every function as it is. Public, micro value stat. I think this is a bit more readable. And it will state that it will make clear that these functions are to be used. In daily life. This one also. This one will have to go in the future. I know that. Well, I won't put in public everywhere. But this one should be private. And here I have a... Here I'm not sure. Maybe it is useful to know the number of decimals. And the micro value shift right max. They should be private. And here I am in doubt. So I make these public. I've left some lines with old functions for to remind me that once they were. So. But now I can remove them. And maybe these can also go. Ah, this looks good. Bear with me, just working on the card. If you the art of programming is that you program like the software will be used for hundreds of years. So it has to be ultimately cool. 2019 028 should go. So. I'm not using this px bool value anymore. It's silly, so bad idea. We will just use the micro for everything. Some publics. And the empty and filled. Then I'll and the check integrity. I'm almost done. Okie dokie. Will it compile? Yes, it will compile. Well, this was all about code formatting. And you have to take your code into serious consideration. Empty lines are also a piece of your code. And your code tells a story. I have a book here. It's called Literate Programming. It is written by one of my idols. He is called Donald Knath. The book is called Literate Programming, meaning that a program should be readable like a book. And he is a evangelist of writing code using a kind of word processor, and that you will actually produce a book with the content of the code in it. And you take comment statements in your code, and then one piece of software will extract a book-like form of the code, readable for human beings, and another piece of software will extract the source code, which can be fed to a compiler and linker. And here I am working with only one piece of code which should be readable for a user and for a computer. So it will save me a step to produce the computer code and then to produce the readable code. And I work with things like long variable names and short variable names. For instance, the variable b. Here an example of b. B is just a boolean. It has no meaning. Therefore, the name of b is simply b. And a simple micro will be called m. If it has no meaning, it's just called m. And a simple long is called L of Leo. For instance, here in this implementation of check integrity, there we have a variable b. It's just a one char variable telling whether or not things went right or not. The check integrity, put the result of the integrity check into the variable b. If the checking of the integrity failed, then we will return 0, meaning we are not okay. If the check went okay, but If the check went okay, then the content of variable b is returned. So this is the actual function. And if if the result is not filled, then this function will return 0. Now here the variable b has no meaning in itself. It is useless to call this variable the result of the integrity check. Way too much characters. A simple b will be sufficient. It's all about readability. You have to take into account that if you write software which will work for hundreds of years, then you might find yourself in a situation where you yourself have to work on software that you have written maybe 20 years ago. And you are the author. And you should know your way in that 20 years old code right away. Maybe some reading. And aha, oh, I meant that. Well, I know what I meant in those days. And then you should be able to expand the software. I will give a separate episode. I will make a separate episode on the error logging and the testing software and the performance check. Before I forget. Let me look at the macro begin. Right. This is not to my liking. Oh, px begin, I'm sorry. Here, this one. At this moment, it just declares a variable for the execution status and a boolean. And in the case of debug, 2 extra booleans. In the future, this macro can be used to declare a struct that will work together with other structs to do performance measurements. Still future for this moment, but in the future this will happen. Given time to me, of course. At this moment I am not working on it. At this moment I am working on level 2 and I'm working on fields. Very interesting subjects. Because the ultimate, perfect, infallible piece of code. Every program is in itself a programming language. Rule number 1. And every program is, for a part, at least a part, an information system. Every program has to deal with tables. For instance, this is a spreadsheet. And these are the columns. Now these columns, I name them fields. In a spreadsheet you have 26 columns predefined, and these are called fields. And these are called tuples or records. And these fields are a central concept in px. more about fields in the future. I think the next episode will be about expressions, something I've worked on for a couple of months lately. And in the expression section, fields will be used. So for now, I'm saying bye-bye, and I'll meet you at the next episode of PX and the Art of Programming.